Okay, I think we pretty much got everybody in here, so I think we can go ahead and get started. So like I said, my name's Dylan. Um, I'm a student worker at Texas A&M. I graduate this year, so this is my last year, and I've been working with HPRC since like 2017 when I first got to A&M. So today is our first primer. We have these primers, which are like shorter courses that are generally an hour long or so. And then we have our short courses, which are longer than an hour, typically about 2.5 hours with like a little break in between. Obviously, with the pandemic situation, we've gone entirely virtual. So whereas in the past we've had in-person and then virtual offerings, this year we're doing all virtual. So for these primers, today we're talking about, let me unpause my screen. 1 second. Unpause. There we go. Today we're talking about introduction to Linux. Next week we're going to be doing introduction to Ada and Terra clusters. But since we've only got an hour, we're going to go ahead and jump right into it with this introduction to Linux. So I'm going to be using Ada for my Linux environment. If you don't have a Linux environment, there's a couple slides where we'll go over how to get into a Linux environment in a Windows machine or something like that. But I'm on a Mac right now, so it'll be really easy for me. Also, in the chat are some other staff members and student workers. So if you guys have any questions, feel free to just drop them in the chat. I'll be periodically checking to see what's down there. And the staff members and the other student workers will try to answer questions as we go too. So don't be afraid to ask questions. So since I'm going to connect to one of our clusters, I have to be on the VPN. So I've already connected to the VPN up here. But if you're planning to follow along and connect to Ada or Terra, just remember that you have to be connected to the VPN. And you could connect to the VPN through right here, connect.tamra.edu. So let's get started. Here's the slide on your login password. You should know this by now. Don't write your passwords down. Don't choose easy to crack passwords, and change your passwords frequently. So accessing the system. So actually the very, very first command we're going to run in Linux is going to be the SSH command from my terminal right here. So I'm just going to open up terminal. This is a bash terminal. So all the work we're going to be doing is going to be in a bash terminal right here. If you can see this, it's kind of small. Bash stands for born again shell. I'm going to make my font a little bigger. So this is a Linux environment right here. It's actually a Unix environment, so I could run all the Linux commands and stuff. But for the sake of standardization, I'm gonna connect to Ada. So I'm gonna connect to Ada using the SSH command. If you want to also connect on Ada, you could go to the HPRC portal. So that's gonna be this website right here. This will be through the web browser. So I'll just open a new tab. https://portal.hprc.tamra.edu. And I will drop this link in the chat for you guys. Yeah. Oh, look at that. Braden's 1 step ahead of me. Thank you, Braden. So this will take you to the portal, and we have some slides over here using the portal. So I'm gonna connect to Ada. So you'll click on the Ada link over here, and then to get a Ada shell at the very top, we'll go to clusters and then shell access. So over here, click on Ada. It might ask me to log in. Yeah, it's gonna ask me to log in. Let's see my password. It did. Let me just throw myself in. Okay. And over here, clusters, shell access. And it's gonna ask for my password yet again. Secured computing resources. Okay, so now I'm connected to Ada on through the portal. So from this little command line down here, I could also follow along. But like I said, I'm going to use my terminal right here. If you're on a Windows machine and you have an HPRC account with us, so you have a login to Ada and Terra, you could go ahead and do this if you want to follow along. If you're on a Windows machine and you don't want to do that, you could use MobaXterm. So MobaXterm is a bash shell for Windows. So to get MobaXterm, it's also free. You could just go to Google and type in MobaXterm, like so. And it'll be this free one right here. MobaXterm free X server tabbed SSH client. So it's an SSH client, and it has a bash terminal built into it. You'll go to get MobaXterm now, and then download the free edition. And you're going to want to install this green one right here, the installer edition. If it says forbidden, yeah, this is going to be a VPN thing, or just refresh the page and try it again. I think if a lot of people try to connect at the exact same time, like what might happen right now, some people might get the forbidden. And yeah, do know MobaXterm is totally fine. MobaXterm works. So once you download MobaXterm, just hit start local terminal. I don't know if there's a picture of that on here. Your terminal will look like this. This is what it looks like on MobaXterm without all these graphics. Okay, so let's go ahead and get started with that little setup out of the way. How to use SSH on a Linux client. This is like still a little bit of setup. So on my terminal, I'm going to say SSH. I'm going to say -y, and that's a flag, which is going to enable graphics. I'm going to say Dylan at ada.chmod.edu. So this command right here calls the SSH command with the -y flag, and it logs me into Ada. I promise if you don't understand that, you'll understand that by the end of this hour. So let me log in one more time. Duo myself in. Perfect. Okay, so now I see Dylan at Ada1, and I'm good to go. So I'm going to do Control L to clear my screen. So just to give us a clean little workspace right here. So is everybody in a Linux environment where they can type in commands? So you're either connected to Ada or you're ready on MobaXterm. Once you guys are in a Linux environment like that, we can go ahead and get started. Again, keep on dropping all your questions and stuff in chat. Git bash won't work. So some of the commands would work, but git bash is mostly just for running git commands in a shell on Windows. I would download MobaXterm. Okay, yeah. So if you don't have an account, you can still download MobaXterm and then just run the commands that we're going to run on your local machine. It's going to start a bash. It's going to basically start a terminal like this on your local Windows machine. Being on Ada is not really such a big deal. I'm just on Ada because it's easier, and if people have an account with us, they can just log in there. And then I think Braden dropped the apply link for accounts. So okay, let's go ahead and actually do some commands. So the first command we're going to learn, I'm going to go to full screen here, is, come on. Thank you for messing up on me, Google present. Okay, the first command is going to be pwd, and this answers the question, where am I? So the pwd command prints the working directory. So as you can see in these slides, the kind of general format we're going to follow is the commands are going to be in green and the output's going to be in blue. So in our terminal over here, I'm going to say pwd, and that's going to return exactly where I am. So my current directory is /home/Dylan. So this is going to be your home directory, and then this is going to be your NetID or whatever username you have. So let's go ahead and list the contents of this directory. So I know where I am, but what's here? So I'm going to type the command ls. ls, really simple again, is just list. So when I type ls, I see I get some output kind of in these stacked columns like this. I see some blue outputs, I see some red outputs, I see some green outputs, and some white outputs. So let's talk about, let's talk about the Linux directory structure. So when we typed pwd, I'm going to Control L and then pwd again. we saw /home/Dylan. So that told us that we're in Dylan's directory, which is inside the home directory. So Linux directories are structured like a tree. If you're familiar with CS data structures, it's an inverted tree. So at the very top we have the root directory, and then from the root directory we have various directories beneath it. A lot of the directories that are at the top level, they're like operating system and system directories that us as basic Linux users won't be diving too much into, but you should kind of know that they exist. So you have the actual /root directory, which has stuff pertaining to the system, to the main operations of the system. You have the temp directory, which is for temporary files. You have etc, and then you have var, and then var log, var www, and then you have home. And then, of course, these are like the very standard directories that you'll have. If you have a more customized Linux environment, there could be 100 more of these, but these are on every system ever, or every Linux system ever. So it's a safe bet that you'll find them there if you ever log into a Linux system. We're going to be doing all of our work from home. So home is where you first log into. So you turn on your Linux computer, or you, in our case, SSH into your Linux computer, and then you're put in your home directory. So where are we in this whole mapping system? We're in home, and then right here, where we'd be Dylan or your net ID. Okay, so Linux commands have options. So I kind of teased this before when I SSH'd in and I said -y. When you use an option, you're going to leave a space between the command and the option. The double dash means that it's a single option, which is usually a descriptive word. So in this example here, we see the ls command that we're familiar with, which was list, and then we see a double dash and then all. So the double dash here says, okay, we're going to run the ls command and we're going to use a flag, but this double dash says the entire word that follows is going to be interpreted as one flag or option. Options and flags are the same thing. So you might hear me switch back and forth between them. They're the same thing. Options are flags and flags are options. They're all these little options that you put behind dashes, single dashes or double dashes. This double dash right here, double dash all says show all files, including hidden files, which begin with a period. So let's go ahead and go back to our terminal and let's try it out. We're going to say ls double dash all. So when we double dash all, we see a lot more files than we did with the regular ls command. So this bottom part right here is the regular ls command output, and what's above that is the ls double dash all output. So flags basically just modify the output of a command. It kind of modifies what the command does. So the command at its very top level is very broad and it accomplishes a single thing. But then by using flags, you can kind of refine that command and really get into what you're find what you're looking for. That was a double dash. A single dash means that each character is an option. So we can do the same thing that we just did with double dash all, but with less keystrokes, so more efficiency. So we'll say ls and then -a space -l. This is gonna change it up just a little bit. So this -a flag is gonna show this is a shorthand version of saying all. So it's gonna show us even the hidden files, which are the files that start with a period. And then this flag right here is going to actually shift how the information is displayed, and it's going to display everything in the long list format. So go ahead and type this in, ls -a -l, hit enter, and then we see the output looks a little different. So let me make this a little bigger. It looks different. The first thing we'll notice that it's in a vertical line, and we get a little bit more information. So we see my name twice, some numbers, a date, and then this column over here, which are permissions. I think we'll touch on that later. But the key takeaway here is that every Linux command we enter has options, and options modify what the command does. So basically the way you'll learn Linux is you'll learn a whole lot of regular commands, and then you'll learn a few options or flags for those commands. And then as you use Linux more and more, you'll pick up on more commands that kind of refine the way it works. Options are put behind a single dash. Most of the time, people use options like this third column over here, because most options can be combined behind a single dash. So instead of saying ls double dash all or ls dash a dash l, you just say ls dash al. So the distinction between the double dash and the single dash is that the double dash, like I said before, interprets this entire word as one flag. So instead of interpreting ALL, it just interprets it as -a. You could stack these single commands behind a single dash like this. So this output right here for ls -al, it will be the exact same as this output right here. That's our key takeaway. Also, another important thing is in Linux, anytime I'm going to clear my screen and I'm going to do ls again. Okay, didn't do it. I'm going to type ls -l. So this is going to give me the long list format without all the hidden files. So still a lot, but not as crazy. And I'm looking for what things I got to do ls -al. Looking for one directory which I thought I had in here. Okay, yeah, here it is. So these directories right here, you'll always see if you print out the hidden files, you'll always see these two files right here, the single period and the double period. In Linux, the single period means your current directory. So this is kind of a reference to where you're standing right now. And then the double period means one directory up from where you're standing. So we're going to talk about that in a second when we talk about the cd command. But okay, so Linux commands have options. So you might ask yourself, how do I know all these options? Well, the easier way to know all the options is to Google them, because Google has the information way better organized than these manual pages. But if you can't be bothered to open up Google, from the terminal, you can open the manual for most Linux commands. So most Linux commands, at least the ones that are pre-built like with the system, will have a manual which you can access using the man command. And you could just read everything you could possibly want to know about that command. So right now, let's go ahead and search the manual page for the Linux command ls. And we're going to search for, yeah, so let's go ahead and open it up. I'm going to Control L to clear my screen. And I'm going to say man ls. So when we do that, our little prompt goes away at the bottom. So now we've lost our little prompt for commands. And we're kind of in this like a reader format. And it says user commands, ls. It gives us the name, ls, list directory contents, the synopsis of how it's used. So we say ls, we give it some options, and we could give it a file even. And then here are some flags that are right here. This is an easy way to search for commands, although the way these manuals are kind of organized, it's very it's it could be organized a little more user friendly. So generally, if you're searching for flags and stuff, I would just go to Google. But if for some reason, like I said, you can't go to Google, you could basically read your microwaves manual and use the man command to search up these flags. So right here, you can see the -a flag that we use, double dash all to. So yeah, I think there was an exercise here. Oh, okay, yeah, so you can also search, you could search the man page by typing /. So my little cursor's down here at the bottom. I'm just gonna hit /, and if I type in all, and then hit enter, it's gonna basically Control F for every time all shows up. So here we go, it highlights it. So if you're looking for a specific command, you could just hit / and then enter your search and hit enter. And if it finds it, it'll find it. If it doesn't, it'll say pattern not found, press return. So so now to get back to our terminal, whenever we lose our little prompt like we just did right now, and we can't like enter commands like ls, like that doesn't make sense. What we can do is hit, oh, I just did it too fast. You hit Q on your keyboard, and Q will quit whatever you're doing. So I'm gonna hit Q, and it's gonna quit that little reader, and I get my prompt back. by the way, I should have mentioned this at first. This is called your prompt right here. It's called your PS1, and it's going to show you. It's going to show you three things. It's going to show you who you are. So in my case, I'm Dylan. So I logged into Dylan. It's going to show you where you are. So I'm connected to Ada. Specifically, I'm on Ada 1. If this was on my local machine, it would say like MacBook Pro or whatever. And then it also shows you where you are in the system. So this little squiggly line is a shorthand in Linux as well. And this is shorthand for /home/ your NetID. So in my case, this squiggly line is home Dylan. In your case, the squiggly line is going to be home and then your NetID. Just like how the period is going to equal, wherever you're standing right now. So because I'm in my home, the period equals this little squiggly line. So that's just a heads up. If you ever lose your prompt, like I said, you can hit Q on your keyboard, which will quit whatever you're doing. If that doesn't work and Q is not working, you could do Control C, and it puts that little character right there. And this is the signal interrupt. So this is the equivalent of like opening Task Manager and killing the whatever process is running. So that's very useful if you accidentally do something and you're like, oh crap, how do I stop it? Just Control C until it stops. The two ways to get your little prompt back so you can enter commands. Okay, I'm gonna Control L. And we're gonna move on. We got some things in the chat real quick. Logging into mobile Xterm, applying for accounts. Okay, I'm gonna keep on going, and Brayden will help set those setups questions. Okay, directory commands. So we're familiar with listing the contents of our directories and stuff. We're going to right now learn how to make directories. So the next command we're gonna learn is mkdir, which is the command to make a new directory. So from my home, inside my home, I'm gonna say make dir, we'll call this Ada_primer. Hit enter. And you notice when we hit enter, there's no like confirmation that says, there's really no confirmation. The only feedback we'll get from the terminal is negative feedback. So like if you type the command in incorrectly, so like let's say I had a typo over here and said like whatever this is, I'm gonna get an error like this, and this error says, what this is saying bash had an error. The error came from this command, and the error was command not found. So that's kind of how you debug this. Bash sent the error, this generated the error, and this was the actual error. So obviously the command was not found because this was a typo and this does not exist. Another thing I should note in Linux is that Linux is case sensitive. So mkdir is not the same as mkdir. It's case sensitive, so most of the commands are going to be, actually I think all the commands are going to be lowercase. You actually really never use uppercase unless you're like setting variables and stuff. Yeah, just keep that in mind. It's all going to be case sensitive. So after typing in this command, make dir Ada primer, we have an Ada primer folder. So I'm going to type ls again. And it's actually the first one because this is sorted alphabetically. So let's move into it. So to change directory, over here, we're going to use the cd command, which is probably the command you'll use the most. Cd and ls are like they go hand in hand. Move to a place, look inside of it, move to a place, look inside of it, that sort of thing. So to use cd, we just say cd and then the name of the directory. So I'm just going to say ada_. And now here's a little Linux pro tip, which I didn't include in the slides, but if you're in a Linux terminal, a bash terminal like this, you can use autocomplete by hitting tab on your keyboard. So I've got cd ada_, and I'm gonna hit tab, and it autocompletes for me. Since there was only one option that began with ada_, it automatically knew that that was what I wanted. I'm not gonna be tab completing too much because I'm trying to do it real slow. But in a normal setting, you could tab to complete nearly everything you do. and it makes your life so much easier. So cd into Ada primer, hit enter, and now we see our little prompt has changed. So like I said before, this shows us where we are, and this directory, our last directory, now changed to Ada primer. And if we ls inside here, we'll see there's nothing because it's a new folder, we just made it. Hit type in pwd to print the work directory, and we can see we're in home, Dylan, Ada primer. Okay, so how do we remove an empty directory? Great question, glad you asked. So first we need to leave the directory. There's a whole bunch of ways to get back to our home directory. Right now we're gonna type cd and then a space and then a ... 2 periods. So like I said before, ... is another one of those variables that changes. It's kind of like the squiggly line. But ... it's a relative variable. So what it's going to do is it's going to move us up one directory. So from this pwd command, we're inside Ada primer. It's going to move us up one into Dylan. So hit enter, and we got our squiggly line back right here, letting us know that we're in our /home/Dylan directory. And if I type ls, I could see we have all these contents again, and we see the Ada primer directory that we want to delete. So to remove an empty directory, it's going to be rmdir. Pretty self-explanatory so far. rmdir, and then the name of the directory. So ada_primer. Hit enter, and then we don't hear a complaint from the terminal, so we know it was successful, or we can assume it was successful. Let's go ahead and type ls to confirm, and lo and behold, we removed our empty directory. Okay, so far we've learned like 4 or 5 commands. We touched on what SSH was. We learned about printing your work directory to find out where you are. We've listed the contents of our directory. We've made directories, and we've changed directories. So right now we're going to talk about terminal attributes. So when we typed the ls command, we see, I'm going to Control L once again to clear my screen, just so we can have a clear work environment. ls again, we see a whole bunch of different colors. We see blue, we see white, we see red, all that stuff. Those colors tell us a little bit about whatever file this is. So file and directory names are colored based on their attributes, such as permissions and extension. From the top, turquoise colors are symbolic links. So again, if you're familiar with programming, a symbolic link is basically just a reference. So I don't have any symbolic links in my directory right here, but if I did, it would basically just be like a pointer to another file somewhere else in the system. The green files are executable files, so they're files that I have execute permissions for. We're going to go over how to add and remove permissions in a little bit. The red files are compressed files. So I think I have an example right here. Helpdeskscripts.tar. This is a compressed file. It's a tarball of files that of text files, which are scripts for our help desk. And here's another directory that's been tarred up. It's basically just a consolidation of files. So if you get a whole bunch of files like this, if I wanted to save these files right here, these MATLABs, I could tar them up into one single file and then send it away. Kind of think of it as like a zip file on Windows or something like that. So you can consolidate the files and then you can compress them. So that's red. Pink or purple, that kind of looks pink to me, but it says purple. Those are image files, so media files like JPEGs or probably MP4s, like a movie. I think if you put a movie, it might be purple, not too sure. But yeah, if you have images, let's say you're doing machine learning work or something, you have a whole bunch of test data that's images, yeah, they'll be pink. These blue directories are going to be, these blue files are going to be directories, so they're folders. So if you see blue, you could just think folder. So like folder, 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 etc., stuff like that. White are just your plain text files. So they're just going to be they're going to be your text files. So when you write a script, at first it'll be a white file, and then you'll add execute permissions, and it'll turn it green, just like this. So that's what these colors mean. Okay, so let's get more in depth with the change directories command. And we're going to run through these. Okay, we'll talk about this, and then we'll run through this exercise right here on the right. So the cd command is how you change directories. I mentioned before, there's a ton of different ways to get to your home directory. So if you ever are moving around in a Linux system, so you're CDing a whole bunch, so you're CDing like into intro to Linux, and then to like into some directory, and then some other, if I could type, that'd be great, other directory. That's not going to work because that doesn't exist. But if you, let's say you moved into like 1, 2, 3 directories down, and you want to get back to your home directory, there's actually 3 ways you could do that. So you could just type cd. So just typing cd and hitting enter from wherever you are will take you back to your home. Also, you could do cd and a little squiggly tilde. That will also take you home. And then cd with the squiggly and the slash, yeah, that basically the same thing as the command above. All of these will always take you home. So if you ever get lost in a Linux system somewhere and you're not sure where you are, and you just want to get back home, understandable, you could just pwd to print where you are, and then cd tilde to get home, just like that. The other command is to switch to the parent directory of the current directory. So in other words, you're going to move one directory up, and that's this command right here, cd double dot, cd dot dot. So if I type cd dot dot and I'm inside home Dylan, you might wonder where I'm going to go. So I'll actually just go up into the root level home directory, which is the directory that contains everybody's home directories. So I can't do anything here because like I don't have sudo permissions. So to get back home, I could just say cd and enter, and it's going to take me back to my home directory. So just be mindful of that. Most of the time on a Linux system, unless it's like a Linux system that you own that you're kind of playing around on, there will most likely be safeguards to prevent you from like accidentally breaking anything like on our systems. Not that you should try, for sure, but generally it's hard to break things unless you're intentionally being malicious. So don't intentionally be malicious, but don't be afraid to make mistakes either, because you know everyone was new at Linux at some point, and you just get really good at it by using it a whole lot. So the other cd command will be cd and then the minus. So basically cd with like the minus and no flags. That kind of works like the back button. So that will take you back to where you were before. So when I type that command in, I get one little output, and the output from that command is the directory it just took me to. So that could be wherever. In our case, I had just come from the home directory, which is above mine. So when I type cd and then the dash, it says, oh, okay, we just took you back to /home. But I want to go to my home directory, so cd, enter, and now I'm back in /home/Dylan. Okay, we're gonna run through this this little command thing on the side over here. This little exercise. I'm gonna Control L to clear my screen. I might actually have some of these directories. Let's see. I don't. Okay, great. I do this class a whole lot, so I always have a lot of these directories already made. So we can go ahead and do it right now. So first thing we do is cd to make sure that we're in our home directory. And then the next thing we're going to do is mkdir temp. So remember the mkdir command makes a directory. Mkdir temp makes the temp directory. And then from our home directory, we're going to use mkdir again. We're going to say make dir, and we're going to say temp yet again. And then we're going to put a slash. And then we're going to say hd19. hg19. So what this is doing is this is saying, I want to make a directory called temp. And then the second command says, I want to make a directory inside temp called hg19. Hit enter. And now we're going to say cd temp. We moved into the temp directory. We lost our squiggly because we were out of our home directory. We're in the temp directory now. PWD to show that. Home Dylan temp. We're going to move down a level and say CD HG19. And let's go ahead and print PWD. And we see we're inside home Dylan temp HG19. So to move up 2 directories from where we are right now, we're going to say CD, and then we're going to get advanced with it here. And we're going to say // So again, the ... is the pointer to 1 level above us. So what we've done here is we've kind of stacked these 2 commands together. We said, okay, move us up 1 and then move us up another 1. So we're going to go boop, boop, and go back to our home directory. And we get our squiggly back. PWD to show that. So we did, in fact, go up 2. And now we're going to do CD space and then the minus. And like I said, the minus is kind of like the back button. So it's going to take us to the last directory that we were in. And it gives us an output. It gives us the PWD output that says, okay, I'm returning you to home Dylan temp HG19. Yeah, and then these just, so print the work directory, it shows us that we're in home Dylan temp HG19. And if I do CD ... without the just 1 pair of dots, that's going to take me up 1. And then we can print the work directory just to show it again. And then CD again to take us home. It's really that easy to move around in Linux, I promise you. So that's how you move around from the terminal. That's basically it. I'm gonna drink some water real quick. Good job, everybody. That was, I know it seems kind of simple, but that's kind of because Linux is really simple when you get down to it. It just looks intimidating from the command line, the CLI command line interface, where everything's just text-based. It really comes down to just remembering the basic commands, and the basic commands are ls to list everything, and then cd to move around. So I know it sounds really simple, but that's kind of the very basis of Linux. So let's talk about paths. You guys ready to get conceptual here? So absolute versus relative path. Oh, also, anybody have any questions on that last part? If anybody has any questions, yeah, keep on throwing them in the chat. Yeah, Braden's doing a good job. Thank you, Braden. I appreciate all the help. Okay, so absolute versus relative path. So if you're in the project directory over here, this directory that's highlighted, and you would type in pwd, you would get home Chris project. So the relative path to the README file inside this project directory would be right here. So if we're standing in the project directory, the relative path is going to be ... and then docs README. The absolute path to the README file would be this whole line right here. So basically, in Linux, the name of a file is the location of the file on the disk. So that's where it kind of gets a little different than Windows. Whereas like in Windows, for instance, I have Google Chrome as my web browser, right? As one of my web browsers. So Google Chrome, or on Windows, I have Google Chrome on my desktop, and I have like a little button that says Google Chrome, and there's a space in there. It's Google space Chrome. That is a shortcut which points to the actual location of Google Chrome on the disk. When we're using the command line right here, the names of these files are also their location. So the absolute path is just the, it's almost like the URL. So it's almost like the URL that you could give Linux and tell it, okay, I want to operate on this file. And the operation you could do is either like, I want to open it, I want to list the contents of it, I want to see what's inside of it, I want to remove it, delete it, et cetera, et cetera. So the name of a file is also its location on the disk. So I don't think we touched on it in this little primer, but when you start renaming files, you're not really renaming them, you're actually moving them on the system. Yeah, mind-blowing stuff, I know. When I learned that, I was like, oh my God, this is crazy. Um, so yeah, so the absolute path will never change unless you change the actual name of the file. The relative path, however, is the path to the file depending on where you're standing. So it's relative to where you are. Okay, you can't see the air quotes, I don't have my camera on, but standing as in where you are in the Linux system. The relative path will always change. So relative operators are like these dot dots that we have right here. So I mentioned before, the dot dot always points to your parent directory, which is the technical term for the directory above where you're standing. So if we continue using this example right here, if we're in the project directory, the parent directory to the project directory is going to be the Chris directory. So standing here, the dot dot path is relative and it points to Chris. If we were standing in Chris, the dot dot is still relative and it's going to point to home. So in other words, relative just means it changes and stuff. Absolute is the exactly where it's going to be. So how do we use that in the actual terminal? I'm going to control L. We can use that because we'll just do one example because we've only got less than 20 minutes left. There's a couple more slides I want to get to. But using an absolute path, when I was new to Linux, I would use a lot of absolute paths, especially when I was writing scripts or doing anything on the clusters, because I was kind of uncertain of where I was. And I wanted to make sure I was doing everything exactly correct. So, and if I wanted to move into this temp HD19 directory using an absolute path, I could say, and this is a very heavy-handed way of doing it, but it works. You could say cd/home/dylan/temp/hd19. So as you can see, that's kind of long. That's a whole lot of stuff to type. And if I hit enter, it's going to take me there. So I gave it the absolute path, which is the full URL. If I do cd and I'm back home, the relative path to the hd19 directory is going to be, so I already know I'm in /home/dylan, so that's sort of implied. I can just say cd temp/hd19, hg19. Again, so up here, absolute path, down here, relative path. You'll typically know if it's an absolute path because it's going to start with a slash. That's going to, starting with the slash tells the system, I want you to start at the root directory. So remember the inverted tree we said at the very top is the root. So, okay, here's the root directory. Inside the root directory, go inside the home directory. Inside that directory, go inside Dylan, go inside temp, go inside hd19. Absolute paths versus relative paths. If you're starting off, you might use absolute paths more as you get more comfortable and you kind of understand the abstraction of where things are located in the system. You'll use relative paths. That's the takeaway there. Okay, history of your commands. So your commands are saved to a file in your home directory, which is a hidden file. I didn't touch on hidden files before, but hidden files are just files. So they're either text files or directories that are named with the period. They named beginning with the period. So .bash history is a file that's in everybody's home directory, and it's going to save all the commands that you've entered ever. Well, okay, not ever. There's I think by default it's 5,000 maybe. There's a setting that you could change, but it saves your last couple thousand commands. So if you ever type in a command and then you forget it, you could use the history command to show all of your commands. So when I type history, I see okay, I think mine's the last 1,000, I guess. I swear it was 5,000 on some system. Whatever. So it shows you all the commands that we've entered, just like that. You can use the up and down arrows to scroll through your previous commands. So scroll, well, I guess you can't, but you could, I'm on Linux, up and down for me, cycles through my old commands. Oh yeah, okay, so that's what we're referring to. So the up and down arrows on your keyboard, like I'm doing right now, you can't see, but these cycle through all of my previously entered commands. So if I go up one, I see history. If I go up again, I'm going to see cd, and then cd home dylan temp hd19, etc. So if you typed a command in before, it'll be saved in your history, and then you could access it with your arrow keys. So right now, this next command we're going to do, history, and then this bar operator, and then tail. This is sort of more advanced. I'm going to control L to clear my screen, type history, and then on my keyboard, it's the key right above the return, so it's going to be right above your enter key. It's the bar operator. In Linux, we call this the pipe operator because it's gonna it redirects where the output goes. We're gonna talk about that like in the next slide. History and then pipe, and then we're gonna say tail. So what this is gonna do is it's gonna basically run two commands. We're gonna say the history command, and then we want to send the output of the history command to tail. And then tail is basically a utility that just says, give me the last 10 lines of whatever, print the last 10 lines of whatever you give me. Hit enter, and I see the output of history, but I see only the last 10 entries. So much easier if you just like, oh, I entered this command a little while ago. You could say history and then tail. And you could use tail with literally anything, not just history, but in this case, we're using history. You could also search your history of commands using grep. So grep, the entire grep tool is too much to talk about in a 1 hour session, but the real short of it is that grep is a regular expression search, regular expression being any string. Well, it could be any string of characters. So I'm going to Control L once again, type in history, hit the bar operator, and say grep. I guess we'll do grep wget. I don't know if I've entered wget in the last 1,000 commands I've run, but we'll see. So what this is going to do is it's going to print my history, and it's going to grep, aka search, for this regular expression, which in this case is wget. Hit enter. Oh, I misspelled history. Embarrassing. Okay, well, so I haven't typed wget other than the 2 times I just typed wget. But as you can see, it showed me the 2 times in my history where wget was found. So let's see, is tar in there? I'm sure tar is in there somewhere. Yeah, so these are all the outputs where I entered a command with tar. Don't know what I was doing, but okay, Control L. Okay, redirection operators. I promise I talked about them, and they're gonna bore the heck out of you. So the basic idea of redirection operators is whenever you enter a command like history, oh man, I cannot type. If you type the command in like this and you just hit enter, it's going to send the output to standard out, which in Linux it looks like this, std out. Standard out in Linux, in a Linux environment, is what you're looking at right now. It's the terminal. So by default, the system will send all output to standard out unless you tell it to do otherwise. You could tell it to do otherwise using redirection operators, which are the little greater than or less than symbols, or as I learned them in school, the hungry alligators. That's a true story of the American public education system. So these operators right here basically redirect input or redirect output. So the less than sign redirects the input. So I have an example of that. So if I said like history, well, if I said like grep, and then I could give grep some text file. So this would send some text.file to grep. That's kind of how it works. The one that the redirection operator that you'd use more often is going to be redirecting output. So if I'm going to say history, and I want to send that output, so hit the pointing arrow to Dylan hist.text. So hit enter, and instead of printing the history to my screen, it prints it to this file. And now to see the contents of this file, I'm going to say cat Dylan_hist.text. So cat is the command to print the contents. It says, you know what? I learned this and then forget this like all the time. It means like you print the contents of it. I always forget what it actually stands for. So you cat text files, and here's the output from the text file that we just made. Okay, those are redirection operators in a nutshell. Oh, I guess I should mention these two. So every time these redirection operators, these single arrows, these will always create these overwrite. So these will always create a new file. So if you want to add on to the file, you have to append it again, computer sciencey terms here. You have to append the output to the file. So for instance, I have ls, I have this history file that I just made, which was dylanhistory.txt. And then if I want to append it, instead of doing the single arrow, I would do history and then 2 arrows like this to dylanhist.txt. This is gonna add on to this file instead of overwrite it. So yeah. And the reason we're not talking about these down here is because these can get, it gets a little bit more complicated with these. So these are kind of the safe and easy ones to talk about. Okay, so let's talk about permissions real quick, and then we'll talk about scripting, and then that's it for the primer. So I mentioned before that files and stuff, all files on Linux are going to have permissions. You can see these permissions with the ls command. Before, when we saw that vertical column output, that's where the permissions were in the permissions column on the left-hand side. So to see that, we need to use the -l flag. So ls -l will show us all of our permissions here. I have a whole lot of files in here, so I'm going to go ahead and make a directory. I'm going to make the Ada primer directory again. Make directory Ada primer. I'm going to cd into Ada primer. This is because I'm going to be making some files, and I just want to show you some. So I'm going to create some file.txt, touch another file.txt. So this is just to give us some examples real quick. Control L. Okay, so when I type ls -l, we get this output. Also, just to let you know, ll on some systems will equal ls -l. It's an alias. In ours, it does. So you could say ll, you could say ls -l. This first column over here is going to give us our permissions. So without going into too much detail on these permissions, it's basically a triplet. So it's a set of 3 that repeat so there's 10 lines here total. The first line, which you see is not there, is either going to be a D or it's going to be nothing. If the D is there, it means this is a directory. So this will be blue. So let me make a directory, call it some ls -l again. So we see that we have a directory, which is blue, and we see this directory bit over here is flagged as a yes, it's a directory. So after the directory bit, we have 3 sets of 3, and the 3 sets of 3 are rwx, rwx, and rwx. So if you're following along, that's going to stand for readable, writable, executable. And it repeats 3 times because there's 3 different, basically, there's 3 different, I don't want to say groups because groups are their own thing. There's 3 different settings we could change here. So we could change the readable, writable, or executable permissions for the user, for the group, and then for everybody else. So that those 3 sections include everybody that are on a Linux system. So the first set of 3 are going to be your user permissions. The next are going to be your group permissions. And then the last are going to be everybody else in the system who's not me or in my group, or in a group that is owned by the file. So basically, if you see the R here, that means that it has the permission. So right off the bat, this text file at the very top, another file.txt, this one has the readable and writable permissions set for everybody for me. So I made the file so I could read it and write it. I can't execute it though. So if this was a script file, I would not be able to execute it. I'd have to add my execute permissions. People in my group can also read it and write it, but they can't execute it. And then other people on the system, so like you guys, if you're on Ada and you wanted to cat out this file, you actually could. So you have readable permissions, but you don't have writable. So you can't open it up to edit it. You can just see the contents of it. So how, Dylan, do you change permissions? Well, I'm glad you asked. You use the Chmod utility just like this. There's a couple ways to do it. The simple way, and the way I like to use it most of the time, is just by being very verbatim with it. So you'll say Chmod u Okay, so you say chmod, which calls the command, and then you need to tell it what permissions you want to set. So let's pretend that this file right here is a script file, and I want to add execute permissions to it. I can say chmod u plus x. So this is saying, call chmod, I want to add execute permissions to the user. And then I give it the name of the file, another file.txt. Hit enter, and then type ls minus l again. And you'll see over here in the column, in the user set, so remember it goes user group other, UGO. In the user set, the X is now there. So we've set execute permissions, meaning I have execute, I could run this file if there was something there, but right now it's blank. And we also see over here that this file has turned green, because like I said before, the attributes and the permissions of the file tell it, like they display the color. So the file has changed colors from white to green. So I know that I could run it. To run a file Linux, you'd say / another file. Or you say // is the equivalent of double clicking in Windows. So this kind of gives us a little table of what we can do. We can say user, we can say group, and we can say other. So just to give one more example, I'm gonna add execute permissions to this file, the sumfile.txt. I'm gonna add execute permissions to the group. So I can say chmod g plus x, and then sumfile.txt, ls minus l again. And now it's green because I'm a part of the group who owns it. I guess I should mention that too. So these columns right here, the reason my name is here twice is because the first one is the person who owns the file, and the second one is the group who owns the file. So in Linux, every user has their own user group. So my username is Dylan, and I'm a part of the Dylan group. I could see that with groups right here. It shows me the groups I'm in. So I'm in my own user group and then some other groups. So I could change this group ownership to, let's say like HPRC, and everybody who's in the HPRC group would have access to that file. And then I could change the group permission bits to affect them. So to remove permissions, it's going to be chmod, whatever you want to do. So I'm going to say u minus x, another file.txt. And that's going to ls minus l, remove the text permissions. Okay, so the next two slides are the optional ones. That's just the shell script exercise. I won't keep you here for that because it basically just kind of ties in everything we did together, and I'm already over time, and I would hate to disrespect you guys this time like that. So I will stick around here and open it up for questions and stuff. So if anybody wants to stick around, I'm gonna go through here. We have this survey right here that should pop up on your screen. So go ahead and fill that out, please. That lets us know what you guys are looking for and stuff. But thank you guys for coming to this very first primer of the fall 2018 semester. Oh my gosh, fall 2020 semester. Just to plug the other primers we've got going on, next week on Tuesday, so it's gonna be the 29th, I'm doing the introduction to Terra. So if you're an HPRC user and you're using Terra, I'll be here and I'll walk through connecting to Terra and kind of the basics in this like hour format, which is kind of fast paced, I know, but I'll try to stick around at the end. So Terra on Tuesday, Ada on Wednesday, and then yeah, so that's for next week, and then we can go from there. So thank you guys for coming. I really appreciate y'all coming. Yeah, I'm gonna stick around if you guys have questions. So go ahead and drop them in the chat. Let me open up the chat, I guess. I'll do that. No problem, no problem. The PowerPoints, yes, the PowerPoints, these slides will be available on our website. Yeah, Braden also put it right there. Thank you. The video, will the video be made available? That's a good question. I believe these videos get put on our YouTube channel. I believe they do, but I don't want to speak too much on that because I don't do the YouTube channel stuff. Um, if you send us an email, I think we can get you some more information on that. Yeah, the text editor slide, sure. Let me find that. Why is this not going the way I want it to go? Okay, text editor right here. So okay, this text editor slide, let me show you here. This text editor slide was using gedit. So on our cluster, gedit's installed. Gedit, I can show you what gedit looks like on my terminal. I'm just gonna type in gedit, and then I'm gonna open up sumfile.txt. So sum_file.txt. So gedit is just gedit, and then you give gedit some file, whatever file you want to open, and it's going to open up just like this. Okay, yeah. So our YouTube channel, Braden linked it right there. So we've done these primers before. We have another version of the primer, so I think it's me doing it like back in the summer, I want to say. It's on the YouTube channel, so if you want to revisit it, it's the same set of slides generally. Yeah, we try to put the primer content on there, and maybe the short course content too. Please subscribe, that'd be really cool. This is what gedit looks like. It looks like Notepad on Windows, and it looks just like this. And then you could type whatever you wanted in here, like my name is Dylan, and then save, close it and stuff. But yeah, I'll leave this open. I really need to get a second screen. Does anybody else have questions? The cat command prints the contents of a file. So in the example I used, I wrote history, and then I sent the contents of history to a text file. And then to show you guys that I had sent the contents there, I used cat to print the contents. Let's see, okay, like we can open up the man page for it. I'm just like man cat, okay, cat, concatenate files and print the standard output. Okay, so it concatenates the start and the end of the file, and it prints all the contents. Okay, see, there's Keith. Thank you, Keith. I always forget that. I don't know why. It prints the output. No problem. No problem. No problem, guys. Thanks for coming. Really appreciate it. No problem. Yeah, so if you guys have any more questions, Braden dropped our email in the chat, which is help@hprc.tamu.edu. That's our ticketing system. So if you guys have any questions, like short course related or like Linux related or about our clusters, you can find us there. Those emails go to the entire staff. So yeah. So if there's no more questions, I think we're going to go ahead and end this meeting so the recording doesn't get too long. So if you guys have any questions, go ahead and drop an email to help@hprc, and we can go from there. But thank you guys for coming to the first primer, and I will see you guys on Tuesday if you go to that primer. Awesome.